Okay, we have been looking at linear equations of two variables, which means we graph them. If we're looking at a system, what that means is we are looking for the point of intersection that exists between two lines. So if we have one line, we have another line. This right here is the solution. Has an x value and a y value. Now, when you're given a system of two equations like this or like this, there's three different types of answers you can get. The first one is like that. We call this consistent. And we call it consistent because there's a solution. They intersect. Okay? And since they're different lines, we call them independent lines. There's another type of graph that you can get. You could get a graph that looks like this. Tell me something about those lines. Same slope. They are parallel. So they will not cross, so they are called inconsistent. But they are different lines, so we call them independent. There is a third graph that we get. We get a situation where they are the same lines. They are the exact same lines. Those are dependent because they are the same lines, so different than independent. And they do intersect, so we call them consistent. You will not have to recall those or memorize them for the test. So when we do the algebra, how do we know? If you come up with, say, x equals 4, x equals a number, then you have one solution. Suppose you come up with this. 3 equal to 8. Is 3 equal to 8? It's never equal to 8. And in that situation, you would say inconsistent. There's no solution. In this situation, you would come up with, say, 3 equals 3, or 0 equals 0, or x equals x. Something where it's equal to itself. Is 3 always equal to 3? Is 0 always equal to 0? Is x always equal to x? So therefore, there's infinite number of solutions. Okay. It says solve the following systems by graphing. There are three ways to solve systems. We're going to take you through the first one, which is by graphing. I graph y equals x minus 2. So I go down 2, and then I use my slope. I move up 1 and over 1. Then I have x plus 2y is equal to 6. There's two ways to graph this. I'm going to choose to put it in slope-intercept form. So if I subtract the x, I get 2y is negative x plus 6. Divide by 2. Y is negative 1/2 x plus 3. So I will plot 3, and it says negative 1/2. That means down 1 over 2, down 1 over 2. It's not easy to tell exactly where that intersection is. So if it doesn't look like it crosses at an exact spot on the graph, you just need to estimate. That's one of the challenges with graphing, is it's not always real perfect. So you might say, like, I don't know, 3.5 and 0.5, I don't know, something like that. Or I'm sorry, 1.5. The next one, you could put those in a slope-intercept form. Can I show you an easier way than putting in a slope-intercept form? Let's graph by using intercepts. If you cover up the y, what's the x value? -2. Now I'll cover up the x. If I cover up the x value, what's y going to be? 4. Then we move along to the next one. If I cover up x, what's y? And if you cover up y, what would x be? 7 as well. And you can see from the graph that they cross at 1, 6. There's a second way that we could solve systems, and that would be by substitution. This is not by graphing. This is going to be an algebraic representation. You have x equals and you have y equals. So I could take what x is and plug it in here, or I could take what y is and plug it in here. What do you want to plug in for? Do you want to plug in for x or do you want to plug in for y? What would you like to do? Okay, so I'm going to take this thing right here, which is x, and I would drop it right where the x is. So I have y is equal to 5 plus 1/2 times. Now this whole thing goes in for x. 2y minus 10. I distribute that 1/2, and I get y is equal to 5 plus y minus 5. The 5's cancel, and what are you left with? Is y equal to y all the time? Yeah, so what do you think my solution is? Infinite solutions. For the next one, I can't choose x or y. I just have to choose one of them. Which one do you think we use here? We use y because it says y equals. So you grab that and you put it right where the y is. So 3x minus 2 times 3x plus 2 is equal to -1. So I put that in place of the y. Distribute my -2. I have 3x minus 6x minus 4 equals -1. Looks like I could combine my 3x and -6x to get -3x. And I add the 4. -3x is equal to 3. Divide both sides by -3. X is -1. So my solution, though, should be a coordinate. -1 is the x value. How do I come up with the y value? Plug in the x value. So if you take -1 and put it in for x right there, 3 times -1 is -3, and -3 plus 2 is -1. Right here. Oh, got it. Thank you. I didn't understand what you're saying right away. So I'm taking this thing and I'm dropping it right here. So this is the 3x minus the 2, and then this thing goes in for y. The -2 comes from right here. Better? Okay. Our third thing that we do to solve systems is we use elimination. Third thing is elimination. Don't write this down, but watch what happens if I add these together. 5x and 8x make 13x, and negative 4y and negative 4y make negative 8y. So in that situation, I didn't have an x or a y go away. If this would have been a positive 4y, they would have canceled, right? What could you do to make this turn from a negative 4y to a positive 4y? And if you do that, we get negative 5x. We get a positive 4y is equal to 0. And then we have 8x minus 4y is equal to 12. Now I'm going to try to add them together. Negative 5x and positive 8x make 3x. Positive 4y and negative 4y make 0. And 0 and 12 make 12. X is 4. Excellent. So if x is 4, how do I figure out y? Plug it in. So if I plug the 4 in for x there, I would have 20 minus 4y is equal to 0. Subtract my 20, I get negative 4y equals negative 20. I divide by negative 4 to get y is 5. Quick talk with those around you for 30 seconds. Talk about an approach to do this next one. Go ahead, talk. Okay, do you want to get rid of the x's or do you want to get rid of the y's? You want to get rid of the y's? Okay, that's fine. You could choose to do either or. So I'm going to have to multiply both by something, right? If I can make this a positive 6y and the bottom a negative 6y, then I'd be good to go. So what do I multiply through to get that to be a positive 6y? So one of them has to be positive, one has to be negative. You would get to choose. But I'll multiply the bottom one then by positive 3. So I get negative 8x plus 6y is equal to negative 22. And the bottom I get 15x minus 6y is equal to 36. I add those together, negative 8x and positive 15x, those make 7x. 6y and negative 6y make 0. Negative 22 added is 36 makes 14. So x is 2. So you plug it back in, we have 8 minus 3y is equal to 11. Subtract the 8, negative 3y is 3. And divide by negative 3y is negative 1. So there's only one lesson left after this, which we'll go through tomorrow. And then we get a couple days to review and we test on Friday. So in this situation here, you guys can go ahead and work on your worksheet on these systems. We'll open tomorrow with practicing those again down below.